Our team has been assigned to construct a balsa wood bridge that conforms to the following constraints while supporting the most load. Its thickness cannot be less than 1/16 of an inch and must be able to support vehicles at any position on the bridge. The bridge must have a minimum roadway width of 4 inches and a minimum vertical clearance for traffic of 4 inches. The maximum width of the structure at any point is 8 inches. A half-inch diameter hole or holes must be provided in the bridge deck at mid-length and mid-width for application of the test load. All joints must be glued using the glue provided. We will be given different sizes of balsa wood as shown in the image, and fixed quantities will apply to each shape. So throughout our brainstorming and concept selection, we started pretty simple and then gradually got more complicated, and we'll explain each one individually.
So we started with just looking at some basic bridge trusses. This is just one example, and they weren't really that good at withstanding forces. So we needed to look for a way to improve our bridge design.
So then I was messing around with different bridge designs and trying to make it so that the compression, which is in the red, would be less than 100 pounds when there was a force applied in the middle of the bridge.
So then we made our final concept selection of this that built off of Eli's design. This works a lot better because of these supports down here are opposing the force that wants to pull the bridge apart. And we liked this concept because of the triangular design and how it opposed that central force, but this was the overall best choice.
These are our initial prototyping phase of our balsa wood bridge. We made an initial joint using glue by cutting the wood and then joining this together.
So we cut the middle piece at to make a point to fit right in the middle between these two main joints, and then we cut these each at 30 degrees to fit together in there too. So this is our initial prototype for our joints, which the main joint here is going to be the top of our A-frame, and it seems to be pretty strong, but we need to make sure that our cuts are exact because like this one was a little bit too short and it didn't fully reach the base here even with the glue. And then on our final prototype, we're doubling up these pieces of wood on the exterior, and then we're starting to fit together the top angle here for the interior. So we have this angle cut, and then this will fit on the side, and then that eventually this will be meeting at the top.
So based on our initial testing, which was very extensive, we decided that it would be a good idea to add gusset plates on all of these bottom joints like along here so that this wouldn't happen. And we also chose much bigger pieces of wood so that we'd have more surface area for gluing all the joints together. And we chose wider pieces for the bigger parts of the frame so that it would be easier to glue parts into them. We also made an inside frame and an outside frame. That way we wouldn't have to cut all these small pieces in between everything, and we would just have a bigger area to glue stuff on. And then we also were trying to figure out how we could attach our truss to our base here, and so we decided that we could just lay it on top and glue this part of the truss onto all of these pieces here, and then put a gusset plate on there to hopefully make it more strong.
Let's do this.
Oh no.
Do you want to get some video over here?
I already hear it from the base. Yeah,
The roadway's separating from the truss a little bit there.
yeah. We should have put something in the middle there, honestly. Yeah, our base is just not ideal.
Now it's symmetrical at least.
Yeah, yeah.
I think triangles are better than arches. I'm just.
So, some things that we were happy with were how well this triangle held up. It didn't start to break at all, and it held up very well.
And then what we would improve for next time is this connection from the truss to the actual base of the bridge. And we would also fortify down here more because we had most of our support spread out. And I think it would have been helpful if we put our holes for the plate like horizontal so that it would be more over where the support is.